What is the complete factor form of f of x equals x cubed plus 8x squared plus 23x plus 28?
Chloe is here with her latest cheat sheet notes. She wants you to know that the degree of a polynomial equals the number of complex roots. And complex roots includes real, imaginary, and a combo of real, imaginary, and repeated roots. The number of roots will not always equal the number of x-intercepts. Roots can be imaginary and or repeated. Possible roots you can find by taking the positive negative p divided by q, where p are the factors of the constant and q are the factors of the leading coefficient. And then the quadratic formula here at the bottom is x equals negative b plus or minus the square root of the quantity b squared minus 4ac all over 2a. Now that we have Chloe's cheat sheet notes, let's go ahead and find the complete factored form of this polynomial. Now, Chloe let us know that the degree of the polynomial equals the number of complex roots, but the roots will not always actually be x-intercepts. The reason why is because some of those roots can be imaginary and some of them can be repeated. So our degree on this polynomial is 3, therefore we will have 3 complex roots. And it will be some type of combination of real, imaginary, real and imaginary, or repeated roots. Now, she let us know that the possible roots you can figure out by taking p divided by q. P are all the factors of the constant, q are all the factors of the leading coefficient. So our factors of our constant 28 are 1, 2, 4, 7, 14, and 28. And all of the factors, or our q, or all of our factors of our leading coefficient are 1. So we're going to divide each of those by 1. So I have 1, 2, 3, 4, 5, 6 numbers, but it's positive and negative. So I actually have 12 possibilities. And I am not going to try all 12 possibilities. It's going to take forever. So I would suggest is to look at the graph. So I went ahead and graphed this in Desmos. And you can see it kind of comes up, squiggles a little bit here, and then keeps going up into quadrant 1. I am interested on the x-intercepts. So the x-intercept here is negative 4. So that is the only one that crosses the x-axis is negative 4. I am not going to try any of these other roots. I'm only going to try negative 4. The other ones must either be repeated or imaginary numbers. So I'm going to go ahead and try 4. And to prove to you that 4 works, I'm going to show you using synthetic division. If you get the remainder equal to 0, it is going to be a root of your function. So on the first thing here, I'm going to go ahead and write all of my coefficients on the top row, replacing any zeros for missing terms. I have 3, 2, 1, no exponents. I'm not missing any terms. So I'm going to go ahead and write out the horizontal line and bring down my first term of 1. Then I'm going to multiply 1 times negative 4 and put it under my next coefficient and add them. 8 plus negative 4 is 4. 4 times negative 4 is a negative 16, and 23 plus negative 16 is 7. 7 times negative 4 is negative 28, and 28 plus negative 28 is 0. Then I started with x cubed, so that means my first one will be 1 degree less, which is x squared, and I will go in decreasing order, so that'd be x to the first, no exponent, which is the constant, and then the remainder. Now, you can see my remainder is 0. Because the remainder is 0, that is how we know that this will be a root of our polynomial. If you had tried any of these other numbers, you would not have gotten a remainder of 0. So to write this one out nice and neat, it would be 1x squared plus 4x1 plus 7. And then I can go ahead and get rid of that 1 coefficient and then the 1 as an exponent. So I really have x squared plus 4x plus 7. Now, because this is a quadratic, or it's raised to the second degree, I know that I can go ahead and just factor this like normal, or I can actually use the quadratic formula, which I wrote down here in Chloe's cheat sheet notes. So to do the quadratic formula, I need to get my a, my b, and my c. My a is the coefficient in front of x squared, which is 1. My b is the coefficient in front of x, which is 4. And my c is just my constant, 7. So when I go ahead and plug this into the quadratic formula, I have negative b, so that would be negative 4, plus or minus the square root of the quantity b squared, so that's 4 squared, minus 4 times a, which is 1, times c, which is 7, all over 2 times a, which is 1. From here, I can just go ahead and reduce. 4 squared is the same as 16, and negative 4 times 1 times 7 is a negative 28. Then I'm underneath the radical and my radicand, I have 16 minus 28, which is negative 12. And then I'm going to go ahead and factor out the negative 12. Since there is a negative underneath that, I know I'm going to be bringing an I out, and the square root of 12 can reduce to 2 square root of 3. Now I have 3 terms here. Negative 4 is the first term, 2i squared of 3 is the second term, and 2 in the denominator is the third term. What do all 3 terms have in common that I can cancel by? They all have a 2. 2 divided by 2 would be 1. This 2 divided by 2 would be 1. Negative 4 divided by 2 would be negative 2. And then if I was just to rewrite that, I really have negative 2 plus or minus 1, or just an I, because remember you don't have to write that 1, times the square root of 3 all over 1. And then I can really just drop that denominator and have negative 2 plus or minus I square root of 3. So I actually have my 3 roots here. The first one I have was x equaling negative 4, and the 2 others are negative 2 plus I squared root of 3 and negative 2 minus I squared root of 3. And notice how we had a degree of 3, so we do have our 3 complex roots. Now, this is not how you write it in factored form. We have to convert all of these x equals into factor form. So the first one I have is x equals negative 4. So to make that in factor form, I need to set it all equal to 0. So I'm going to add 4 to the other side. The 4's will cancel on the right, and I end up getting x plus 4 equals 0. So this is one of my first factors. Now I'm going to take the negative 2 plus or minus I squared root of 3. So I have to make this all equal to 0. So what I'm going to actually do is just put this whole quantity in parentheses, because it's negative 2 plus I squared root of 3, and it's also negative 2 minus I squared root of 3. So we're actually doing 2 problems at once. So from here, if I want to get it equal to 0, I'm going to go ahead and subtract this entire quantity to both sides. So when I do that, the negative 2 plus or minus I squared root of 3, this will cancel on the right, and it actually ends up moving to the left. X minus the quantity negative 2 plus or minus I squared root of 3 equals 0. So I'm going to go ahead and split that up into x minus negative 2 plus I squared root of 3 and x minus negative 2 minus I squared root of 3. And that all equals 0. So this is how we would write this problem in complete factored form.